In this question, it is given that two rods of length d1 and d2 and coefficient of thermal conductivity k1 and k2 are kept in touch each other end to end. That means these two conductors are kept in series combination. So as we are connecting, these two are in series combination. So and we can just consider that their cross-sectional area is same, and length of this one is given as nothing but d1, and the length of another one is given as nothing but d2, and coefficient of thermal conductivity k1 and k2. Both have same area of cross section. The equivalent thermal conductivity is area of cross section is A. Rm is to find out the value of equivalent thermal conductivity. We know the meaning of equivalent thermal conductivity. If you can directly use the equation for, if you want, you can directly use the equation of equivalent thermal conductivity, or you can just derive it. So we'll consider that these two, while combining these two conductor, we are going to get a single conductor of conductivity, let's say K, and area A, and its length is going to be nothing but d1 plus d2. Conductor of same dimensions, means dimensions of this conductor and this conductor should be same. And if you are providing same potential difference or same temperature difference, so that the rate of flow of heat flow through this system and the rate of flow of heat energy through this system should be same for the same change in, for same difference in temperature. So we can say that the resistance of this arrangement and the resistance of this arrangement should be same, and we know that these two resistors are connected in series. So you can write the resistance of first one plus resistance of second one should be equal to its equivalent resistance or resistance of the combination. And we know the equation for resistance of a conductor, which is equal to, we can take it as L divided by K. Here L is given as length is given as d1. So we can write d1 divided by k1a plus for second one we can write d2 divided by k2a is equal to, for the equivalent combination of this resistor, for this resistor we can write its resistance is total length is d1 plus d2 and conductivity k and area a. So you can cancel this a, so you can write the value of k over here. So you can write the value of k is going to be nothing but d1 plus d2 divided by, we can write d1 by k1 plus d2 divided by k2.